Now that we've studied quadratic equations and how to work with them, how to factor, how to do the algebra involved, now we can move on to quadratic functions. So I want to start with a very common application that you'll see a lot. Acceleration due to gravity, right? How the position of a falling object at time t can be given by this equation right here. And you've probably seen this guy before, okay, where t is in time for this one, t is in time in seconds. And h, capital H I'm using here, it's often you'll see it as s of t sometimes. H is the height at time t. Okay, and this can be modeled by a quadratic function. This is so I'm dropping a object from 40 feet high with initial velocity of 80 feet per second, and this has to do with the acceleration due to gravity constant. But don't worry too much about that. We're just going to be able to work. I'm going to give you the function. We're going to work with the function. Okay, so I want to know some things. When does the ball reach the max height? Based on this, so it's a quadratic, which we're going to learn is a parabola. So it does something like this. It starts at 40 feet, and because this is positive, it's thrown upward. And the height can be modeled by a quadratic function, which we're going to learn looks like this. Okay, and that's a parabola, and it continues on forever if there's no application. But we've learned before that in a problem like this with an application, only positive time makes sense, or non-negative time. And the same is true for the height. Height has to be positive, and our job is to figure out how high it goes, and maybe like when it hits the ground, what can we learn about this model? Okay, so in this lesson, we're going to figure out how to do this stuff algebraically. What is the max height? Sorry, I thought I had the same question in there. When does it reach a max height? That's the input. What is the max height? That's the output here. And when does the ball hit the ground? Okay, so we'll come back to this problem. Here's my sketch so far, but we're going to learn how to do all this stuff as we go through. Okay, so we'll come back to the application. Let's just study the general characteristics of a quadratic function. Okay, basically you have when you graph any of these guys, you have a parabola. The highest power is 2, and this will be important for us. All right, if the leading coefficient is positive, it's gonna open up. Like if I have f of x equals 2x squared plus 8x plus 1, then it's gonna open up. All right, just because the leading term is positive. And then if I make that negative, then we're gonna have an opening down parabola. It'll have a maximum. In this case, of course, it'll have a minimum. That's what's stated here. Axis of symmetry. So this could be anywhere. We're going to figure out where it is. If I draw a vertical line right down through the vertex, we call that the axis of symmetry. It's symmetric around that line. And we'll have a y-intercept and x-intercepts. We've studied those before, so we'll figure out what the y and x-intercepts are going to be. A lot of our work is going to come in figuring out these x-intercepts. And that's why we did all that work before studying quadratic equations. We'll need those in order to solve that equation, right? Because we want to know when it hits the x-axis, has a y value of 0, so we'll end up solving a quadratic equation, which we did in that last unit, 6a. All right, so here's an example. This is x squared minus 2x minus 3. You can see what it looks like. We talked about the leading term is positive, so it opens up. And then our job is going to be to figure out how to find these, how to find the vertex, and so on. All right. We can see these guys in two forms. Here's one form. These are equivalent. I can show you real quick how they're the same thing. If I square that out, x squared plus 2x plus 1 minus 4. Remember, x plus 1 squared isn't x squared plus 1. It's x plus 1 times itself, so we FOIL. All right, and that's where I get the 2x from. And then that's an equivalent expression, and we'll look at both of these. This is called vertex form, and this would be called standard form. Okay, so they're the same. we'll be able to work with both of them. Don't worry, we're going to get an example in 1 minute, and I'm going to show you how to do all this stuff. Basically, I'm going to give you this function, either this form. Here's your task. I'll give you that thing, and I'll ask you for all this stuff. The intercepts, the y-intercept, the x-intercepts, the vertex, axis of symmetry, and the graph. Or I can give it to you in this form and ask you for the same stuff. And then once we get to the applications, I'll ask you to apply that. And essentially it's the same work. Back to my application example. Right? This is a vertex question. That's the vertex. This is a vertex question. It's just got an application to it. This is an x-intercept question. When does it hit the ground? Okay, so essentially we'll have the same tasks when we have the application. We'll be focusing on those main things. The intercepts, axis of symmetry, the vertex, and its graph. Alright, let's do one. Determine the vertex axis of symmetry 0. So first let's just given the graph, make sure we understand this. This is the vertex, that's at 3, 1. The axis of symmetry is a vertical line. A vertical line has an equation, x equals some constant, because the x values along this line are the same no matter what. That's x equals 3. That will always match the x value of the vertex. Those will always match, axis of symmetry. Zeros, I want to find the zeros of this thing, and I'm using this function to show you we don't always have zeros. Okay? There are no zeros. That is the x-intercepts, also called roots or zeros. In this case, there's none. If the graph opens up and it's above the x-axis, it won't cross. We do have a y-intercept right here at 0, 7. And we definitely have a minimum, which is the vertex because it opens up. Okay, so here's the main problem we're going to do. We're going to find all this stuff, all right? And I have a little formula for the vertex. That looks a little messy. So if it's given to you in this form, and I want to find the vertex, I can use this formula. This is b and this is a, and the x value is given by negative b over 2a. Little shortcut for us. What does this thing mean? Well, don't be confused by that. I know that looks a little tricky, but that just means plug in the x value to find the y value. All right? If it's given in this form, it's a little bit easier to find the vertex. We know this from our transformations. Right? We used h units to the right and k units up, so that means the vertex will be h comma k. All right, so let's do one of each of these. All right, x squared plus 4. All right, let's do everything. So using the steps above, determine if there is a max or minimum point. So let's just do the whole thing for this one. I think we can do it. So it's given in this form. I want to find up or down, axis of symmetry, and let's just make a list here in no particular order. Does it open up or down? Find for me the axis of symmetry. Find for me the vertex. Find for me the y-intercept's the easy one. And then let's find the x-intercepts, if there are any. And then we'll graph it. Okay, now the work here, the most of the work, and this is why we spent all this time solving quadratic equations, is going to be with the x-intercepts. That's where the most of the work is. The first part's easy. It opens up. All right, just because that first term is positive. So that's good. The axis of symmetry, remember the x value for the axis of symmetry is going to be the same value that's the x value of your vertex. So I can get that by going negative b over 2a. In this case, negative b is negative 4 over 2a is the coefficient of x squared. So negative 4 over 2 is negative 2. Axis of symmetry, negative 2. The vertex value for x is negative 2. So that means my parabola, I already know a lot about my parabola. It's going to go through, the vertex is going to be on this dotted line, right? That's the axis of symmetry, x equals negative 2. And it's going to open up. Now I just got to figure out where, and that's when to find the y value of my vertex, I plug in, Let me show you the formula that I thought was a little... I'm using this formula. I found the x value of the vertex. And then what does this mean? This means just take what you get for the x value. In this case, we got -2, and plug it into your function. That'll always give me the y value. Okay, so I'm going to plug in -2 to my function. -2 squared plus 4 times -2 minus 5. And I get 4 minus 8 minus 5. 4 minus 8 is -4. Take 5 away, -9. And here is my vertex, right there. It's going to open up. So I got a pretty decent sketch, but I still need to know when it crosses the y-axis. That's the y-intercept. So that'll always be an easy one. For the y-intercept, we plug in 0 for x. And then that term and that term goes away. If it's in this standard form, it'll just leave you with that last term, or the constant term. So it's going to cross here. So that kind of makes sense. 1, 2, 3, 4, 5. 1, 2, 3, 4. All right, there. Okay. So it lines up with what I know so far. The vertex here is opening up, and now I just have two things left to do. One thing left to do, the x-intercepts. And like I said, this is where a lot of the work comes in. This one shouldn't be too bad. I think it's going to factor. So recall all the methods we had for solving this equation. We could factor it. We could solve by completing the square. We could solve by the quadratic formula. If I'm lucky, I can factor. Right? That is, if it's a factorable quadratic, two numbers that multiply together to give me 5 and add together to give me +4 should be +5 and -1. And then you can see the solutions to this equation are +1 and -5. We set each of those to 0. And if I want to write those as ordered pairs, it would be 1, 0 and 5, 0. Plot those. Oh, I got a mistake somewhere. -5, 0. I knew and that's what's good about this. I knew if I had 5, I made an error. That's not a parabola. So I went back and I noticed I went a little too quick. So I knew it was -5. And now I got a nice looking parabola.